Hello, this is a run-through of Lunch and Learn that was given in New York on visual regression testing. So visual regression testing is about looking for errors or defects that have been introduced after you've made a change. So when we went through this Lunch and Learn, I presented a website that's the New York team have been working on, which is for McKinsey, which is the Fast Growth Platform site. And what I did was I showed this particular screen, and then I showed another screen and asked the people in the room to work out what had changed. So I'm just going to do that again now. So look at this screen, take a good look, and then tell me what's changed. Now this is a problem that we have all the time when we're comparing designs or checking or QAing sites and applications after they've launched. So the item that actually changed, if we overlay the previous image, was the navigation. So what happened was the item that said what we do changed to the word capabilities. And this can be a small nuance or a detail that can be hard to miss. Now, we're starting to use automation here on all of our websites, and I know we do around other TigerSpike offices. And this is an item that you can easily pick up using an automated test. You check to see that the navigation items are named in a particular way, and when the computer finds out that it's not, an error is raised. Okay, so let's go and show a different type of change that I presented to the group. So this is the first screen, and this is the second. Now obviously the bar at the top is pink. You would have seen this defect as a human, even if you hadn't seen the previous design, you would have worked out that something wasn't quite right. But this sort of defect is actually incredibly difficult for an automated process to pick up. But it is easy for a human. And finally, the next one. So this is the first screen. And the second. And this change is, again, rather subtle. So what's actually happened in this case, if you overlay the images, is that the padding or margin at the top of the navigation has changed. Okay. So the challenges that we face, especially as we're now using automation rather than manual testing more and more, is that there are limits to that automation. Defects are hard to spot. The fact that we have responsive web when we're doing websites means that there's even more checking. So that particular website has 2 breakpoints and so 3 different resolutions. There are multiple browsers, and on apps there can be multiple different handsets. Let's say you're looking at Android, and humans bore easily. So when you're trying to check all these different items, humans, they're not going to pay attention if they're going to look at hundreds and hundreds of screens and have to go and find and check those hundreds of screens. So how do we currently manually test for visual regression? So I asked the group, what's the best way, how would we know whether or not an item on screen was appropriate? Of course, everyone comes back and says, use the design. So here are the designs in Zeppelin. And if we go to that particular design for the homepage of the Fast Growth platform, so this is the design that's on file. But if we compare it to the live site, this is the site on live. So, and if you can see, there are some fairly subtle, well, not subtle, actually, some of these are quite big differences. The padding from the top of the navigation has changed. It says Fast Growth platform, not startup platform. Again, those navigation items have changed, their names have changed, but also Visionaries Wanted is now no longer translucent. The boulder with the paper through it is slightly bigger and to the left, and so on and so forth. So designs aren't the best way of representing what the page should look like, not all the time, simply because designs change, customers change, they change their minds, they want to make additions, and we don't necessarily go back and update the designs. We go and update the thing we're working on. So how do we perform a visual regression? How do we know what we should compare to? Well, what we should do, and what we do is we will upload our changes to a QA environment or a QA build, and then we'll compare them with the UAT build, excluding those items that we know that we've changed. So how can automation help with this? How can automation help this process? Well, to start, we can have automation take pictures or screenshots of all the different screens. and then present them to us side by side so that we can compare. So let's have a look at these two screens. What's different? Well, if we look at this screen, we can see that the filters by topic on the right-hand side is taller, and that's because there are more filter options on the left-hand side than there are on the right-hand side. But if we think about it, our UAT environment could have newer data. The customer has been updating data on there. They've been adding new filters or new topics. So that's not necessarily a defect. So other than that, everything looks fine. But when we overlay the images over each other, we also find that if you look at the header navigation again, then there's a blur around the navigation. And that's because, once again, we've had this visual regression error where the previous menu item of what we do has reverted to capabilities. But looking at this screen, you suddenly realize that, well, if I can put two images over one another, I can probably get an automated process to do that as well. So we found a way of automating visual regression testing. So here are two very similar screens from a UAT and a production website. And again, we're looking at these and we're saying, well, what's different? And actually, once again, the navigation's wrong. We've got that regression error where we have what we do and capabilities at the top. But if we get the computer to compare, there's also a very small visual bug where the space between email address and the asterisk that tells us it's a required field has been removed. Now, this is a really small point, but it's actually a point that the customer referred back to us and asked us to fix. And if you look at the screen and think about how much is different on there, it's only 0.1% difference. But these little details can matter to our customers. Now, the tool that we've used here is one called Wraith. And Wraith is this responsive screenshot comparison tool. Now, when choosing tools, you always want to make sure you're choosing an open source tool that is going to be supported and has a good user base and has been well tested. Unfortunately, this is a tool that's actually been developed by the BBC, and they use it to test their responsive website, this responsive news website. It's got some very interesting options. It allows you to automatically screenshot in multiple sizes on the web. You can specify a difference threshold, so you can say, only give me an error report if there's more than, let's say, 5% difference between the images I'm comparing. It has a fuzz tolerance. Now, this means that you can have a slight color differentiation on things like text. So if you're comparing one screen with anti-alias text against one with un-anti-aliased, the fuzz tolerance will allow you to say that those two things are the same. It has a spidering mode, which allows you, rather than having to specify pages, it will go off and spider your entire site and then give you a series of URLs to check. And it has a history mode where you can give it a series of different jobs to capture images over time, and then it will compare previous images across a timeline with the ones that you have now. It should also be noted that Wraith's image comparison and difference engine is also separate from the capturing part. So, for example, let's say that we have a login page on a site and the spider mode can't get past that login page. You can automate the login using Selenium tests and then capture a screenshot and then have those screenshots compared. The same is true with native iOS and Android applications. You can use Appium or Calabash to take a whole series of screenshots and then use Wraith to compare them. And what you get at the end when you've compared your screenshots is this. You get a report which gives you the current, new, and different images as a series of thumbnails, and then it orders them by the most different at the top. And in this case, it's also giving us all the different screen resolutions and sizes. And again, this report can be generated with a little more effort for a native iOS or Android application as well. So when it comes to automating that web process, how do we automate it end-to-end? What's actually involved? So for the Fast Growth Platform website, when we've finished a piece of development, we want to push it to UAT, we merge that source code into our UAT branch. Our Jenkins CI deploys it to a UAT server, and we're ready to go. Now, at this point, you think, well, we'll compare this with production. But the downside about the Fast Growth Platform site is that we may also have a series of database changes that accompany that push to UAT. The production site has also got lots of changes on it because it's a content managed site by the customer. So if we do strict comparisons between them, the content will be different. So how do we get around that problem? So as it turns out, our development in UAT environments are based on Docker images. They're self-contained containers, and we can deploy them at will, tell them what code to use, tell them what data to use. So our Jenkins CI server generates a new test container using a Docker image, deploys the code onto the test container, and then takes the production database and deploys that onto the test container. It then runs the screenshot process, performs the analysis, and generates a test report. And that gives us this. So there are other things that Wraith can do, as well as just comparing two different environments, such as UAT and production. It can also be used to test the same page across a multitude of different browsers, again, by adding in Selenium in order to take the screenshots and then request that Selenium take those screenshots using a Selenium grid, a raft of computers with different OS and browser combinations. So in this case, we can compare the different images on IE, Chrome, and Firefox on both Windows and Apple Mac OS. So another good feature, using a headless JavaScript-based browser called Casper, we can also take screenshots of particular elements on the screen. So in this case, this screen here, I don't really want to check the post, I don't want to check the navigation, because I know that they will be updating constantly with new data. So rather than having to copy that database from production and put it onto UAT, I can target a particular element on the screen, screenshot it, and then compare it. So in summary, this process still requires manual testers. However, what we can do is we can reduce the effort by automating the creation of screenshots. We can make suggestions as to where we should check for differences, and this helps us reduce the amount of effort that we're having to expend, and as a result, that gives us more time to test other things such as exploratory testing, which allows us to increase quality. So there's a further reading page attached to this video, and if you have any questions, please feel free to reach out and get in touch. Thank you.